I want to revisit the definition of average value. We had encountered this earlier in Chapter 5, where we were only able to calculate the approximate average value. But at the time, I had made the point that of the average value of a function on a particular interval, AB, is equal to the area under the curve under that function divided by the length of the interval. So, in other words, to find the average value of y equals f of x on the interval ab, we would simply calculate the area under ab, which is the integral, which we know is the integral of f from a to b, and we just divide it by the length of the interval, which is b minus a. So I'm just taking, that's where you get this definition here. We take 1 over b minus a, that's 1 over the length of the interval, and multiply it by the integral of the function on that interval. So let's just see how that would work in a specific example. So let's find the average value of the function f of x equals square root of 4 minus x squared on the interval negative 2 to 2. We already saw in the last example that due to geometry, the integral from negative 2 to 2 of the square root of 4 minus x squared dx is equal to 2 pi. So we know is that the average value is equal to 1 over b minus a, so that's 2 minus negative 2, the integral of negative 2 to 2 square root of 4 minus x squared dx. So substituting in what we know, this is going to be 1 over 2 minus negative 2, so that's 1 over 4. That's 1/4 times 2 pi, and that equals pi over 2. So that's the average value of this function, square root of 4 minus x squared on the interval negative 2 to 2. What does that actually mean to say that's the average value? Let's draw that semicircle again. So here's the semicircle. We know that it reaches 2, negative 2, and 2. Those are its dimensions. So the issue is, so what does this number represent? Pi over 2, which by the way is approximately 1.57, just to give you a little bit of scale here. Not that I want it in decimal form. I would want the answer in its exact form as pi over 2. I just want to show you roughly where it falls on the values that we have. What we're saying really is that if I were simply a car driving along the x-axis, looking up at the big arch made by the circle, and I said, okay, I'm going to sort of mentally catalog what is the average height that I see over myself. If I'm looking up at this semicircular ceiling, imagining that I can measure the height just by looking at it, what is the average height that I've encountered as I drive at a constant speed? The answer is that the average height that I would encounter is pi over 2, or about 1.57, where I've drawn it. Now, why is that? Well, if you look at it, this function rises very quickly as I start at negative 2 and start driving to the right. So even though sometimes the function has a value of 0 and sometimes it has a value of 2, so you would think that it averages out to 1, in other words, the difference between 2 and 1. Notice how I spend very little time under short parts of the function. In other words, I get up to here. Here's where I'm at pi over 2. I get there very quickly. And then I spend all this time here, still above pi over 2, and then it drops off again. So I spend very little time. I spend very little time over here looking at the short part of the function. So that's really what it means to say it's the average value. It's the average height that I would encounter if I spend an equal amount of time under each part of that semicircular ceiling.